Hello and welcome to the wide world of physics. Today we are looking at kind of a crossover between where chemistry ends and physics begins. It's kind of a blurred line. There's not two distinct areas. Where we start looking at that is here, how a battery, just a regular 9-volt battery, the one that everybody's seen all over the place every single time, brand irrelevant, and a lemon have a lot in common. Now it comes down to what's inside of them. What's inside of the lemon, if you've ever just bitten into one, is that sour tasting stuff is the acid. That's what makes that sour taste in your mouth. What it also does though, is it provides a force. If you put two different metals in here, I've got two different metals in, and I'll explain more about that in a bit, but if you've got two different metals in, it gives the force behind moving electrons through a circuit. So what we're looking at is you have two different posts on the battery. One's labeled positive, the other's labeled a negative. And at which point in time, if you connect them with some wires, you will get a full and complete electrical circuit. And to do that, you need some wires. So as you can see, we have a very simple circuit set up. We have two clips and the battery. It doesn't matter which side of the battery you hook the clips to at this point. All that's going to do is send electricity from one side of the battery, going around through the light bulb and back into the other side of the battery. And once you connect both of them up, you can see we get a little bit of a light. And it's putting out a tiny bit of current, but not very much. You can see it's putting out 0.15 amps. So as you can see from our circuit, we follow from the black wire around. The electrons move that way and they move into this thing. This is an ammeter. The ammeter measures current. It measures how fast the electricity is flowing through the circuit. This says 0.15 volts, sorry, 0.15 amps, which shows you that not much is going through. I use the reference that the ammeter is measuring how fast, like a current in a river. So how fast the water is moving is also called the current. I use that as an analogy. It's the same thing with electrons. If this thing read 35, there would be a lot of electrons flowing through, but here it says 0.15, so not very much is happening. It comes out of there, it goes into the bulb, goes through the bulb, and then we get the light, and then comes back around and into the battery. Nice, simple circuit. So now if we were to do the same thing using the lemon, we need, firstly, two different metals. The reason we need two different metals actually goes back to the mid-1700s, early 1700s, from somebody named Alessandro Volta, who we name Voltage after, by the way. Alessandro Volta made the first battery by taking different layers of metals and soaking them in salt water and putting kind of cardboard in between them, and he made the first battery. But he figured out that the acid in that battery from the different metals could generate electricity. It was that push that would move the electrons around. Now, the problem, I've now hooked this up. It doesn't matter which way you hook it up, it could be either way. But the problem is, there's not enough to run the light bulb. Because we had 9 volts from the battery, but this lemon is not going to produce nearly that much. So I've removed everything at this point, and I've gotten out this tool which is called a multimeter. Now the multimeter will measure all different kinds of things. In this case I've set it to 2 DC volts, which is what that's going to measure. So it's going to measure the voltage, the potential difference across those two posts in direct current. So it's going to flow from one side to another. This one will also measure alternating current. It will measure amperages, it will measure battery voltages, it will measure temperature and resistance. That's why it's called a multimeter. It will measure all different types of things. So all I'm going to do is take one probe and place it on one side, and the other and place it to the other post. And you can see we've got about 0.9, 0.8, 0.7, somewhere in there less than 1 volt. So what you're looking at is 1 volt of electricity. So if I had 9 lemons strung together, I could make the same amount of power as I made from that one battery. If you're going to make a battery large enough to potentially charge a mobile phone or power a light bulb, you're going to need quite a few lemons, because as you can see, there's not a lot of power coming out of this one. So if you happen to have 12 lemons and a bunch of screws and a bunch of copper wiring, what you could do is link the lemons, copper wire, from another to another lemon which has the screw in it, and then from the copper wire around to the next lemon. So you have to keep going from one side to another, to another, to another, to another. And then you could potentially charge a phone if it's an absolute emergency. So if you have no power but you have lemons, you can at least charge your phone.